Welcome to this explainer. Today, we're diving into one of the absolute most fascinating challenges in modern education. Think about the incredibly complex world of quantum physics for a second. It's this wild field defined by probabilities, subatomic particles, and math that can honestly make even a seasoned physicist's head spin. Now, imagine trying to make all of that accessible, not just to a grad student, but to the general public. Sounds literally impossible, right? Well, a recent paper by researcher Kenji Noda and his team offers a totally groundbreaking look at how we might actually pull this off.
Which brings us to this really beautiful paradox. How do you teach something that literally no one can see? Quantum mechanics operates on a scale so staggeringly small that our human eyes will just never behold it directly. Because of that, we have to rely on math, and crucially on metaphor. And since it's so fundamentally hidden from our daily, lived reality, there's just this inherent mystery to the whole thing. It completely defies our basic intuition about how the physical world is actually supposed to work. So, when you ask the public to engage with something that's invisible, totally counterintuitive, and wrapped in complex equations, you immediately hit a brick wall.
And honestly, it makes sense. Abstract scientific fields are almost universally perceived by the public as distant, highly technical, and frankly, completely inaccessible. When everyday people hear the words quantum physics, they usually don't feel a sense of wonder, right? They feel a sense of intimidation. They picture a giant chalkboard covered in Greek letters and instantly think, yeah, this is absolutely not for me. There's this massive psychological barrier that completely alienates everyday people from abstract science. And the kicker? Traditional science communication, an expert standing at a podium just explaining things, well, that often inadvertently reinforces that exact same barrier.
So let's look at Section 1. Art as the solution, a new entry point to science.
During the International Year of Quantum Science and Technology, organizers decided to just completely flip the script. They deployed these unorthodox, highly artistic interventions on a massive, global scale to try and solve this exact problem of scientific alienation. Instead of trying to force the public to somehow learn the complex language of physics, they translated the physics into a universal language that everyone already understands: art. The researchers focused their case study on two huge initiatives, Quantum Fest in Japan and Quantum 100 in Germany. These definitely weren't your typical stuffy academic conferences or dry museum exhibits. We're talking massive, culturally integrated festivals specifically designed to celebrate quantum science through entirely non-traditional means. They basically served as the perfect real-world laboratories to test out this new artistic approach.
So, what did these festivals actually do? Well, first off, they completely tossed out the traditional lecture format. Gone. Instead, they built these alternative, incredibly immersive entry points into the science. We're talking about live musical performances where the compositions themselves were directly inspired by quantum mechanics. They had stunning visual art installations that allowed you to physically walk right through representations of quantum states. And there was a massive focus on embodied participation, which is really just a fancy way of saying the attendees weren't just passively sitting in a chair listening. Their physical bodies were actively engaged in the whole experience. They were literally feeling, hearing, and seeing the science translated into art.
Now, you might be wondering whether this avant-garde approach actually got people to show up. And the answer is a resounding yes. Across these two initiatives, they drew a massive turnout of over 4,000 participants. That number is absolutely crucial here, because it completely validates the impressive scale of this study. The researchers weren't just observing, a handful of people in a tiny room. They had this vast, incredibly diverse data pool of everyday people engaging with quantum mechanics through music and art.
Which brings us to Section 2, the findings: 3 dimensions of resonance. After these festivals wrapped up, Kenji Noda and his research team went straight to work. By analyzing post-event surveys, reading through participant comments, and doing some really in-depth stakeholder interviews, they discovered something amazing. The participants didn't just walk away with a list of memorized facts. Instead, they experienced 3 very distinct dimensions of resonance: sensory immersion, collective meaning-making, and transformative engagement. These 3 pillars represent a total paradigm shift in how we actually think about science education. Instead of focusing solely on cognitive understanding, like just the brain's raw ability to process data, this model looks at the whole human experience. Let's break these down one by one because, honestly, this is where the magic really happens. Okay, first up, we have sensory immersion. The researchers found that by washing the audience in these rich, deeply immersive sensory experiences, they successfully dismantled those massive psychological barriers we talked about earlier. Think about it. When you're completely lost in a gorgeous, swelling piece of music, or you're walking through a stunning visual light display, your fear of the unknown simply melts away. You aren't intimidated by Schrödinger's equation because you're way too busy feeling the beat of the music. The sensory experience essentially acts like a Trojan horse, bringing the audience into the incredibly complex world of quantum physics feeling safe, curious, and open-minded, rather than defensive and confused.
Next up is collective embodied meaning making. Now, think about how we usually study the hard sciences. It's almost always a solitary, kind of lonely endeavor, right? It's just you, a heavy textbook, and a desk. But at Quantum Fest and Quantum 100, learning became this vibrant, community-driven shared experience. The participants were physically present together, moving through the spaces side by side, experiencing the art as a collective whole. The researchers noted that this shared physical participation allowed the audience to literally form an understanding together. It created this warm, social bond around the science, turning it into a living, breathing cultural event rather than just some sterile academic exercise.
And finally, we have the third dimension, emerging transformative engagement. And this is perhaps the most profound finding of the entire study. The researchers discovered that this artistic resonance ultimately created a much deeper, emotionally meaningful connection with the science itself. Participants didn't just walk out the door saying, "Oh, well, that was neat." They actually left with a lasting relationship to the concepts. By engaging the heart and the senses way before the logical brain even had to do any heavy lifting, the artistic interventions completely transformed how the participants viewed their own personal relationship to the scientific world.
All right, let's move to Section 3, a new science paradigm, going beyond conceptual understanding.
So here is the really crucial takeaway. The goal of this new paradigm is not to make sure every single festival attendee can suddenly pass a calculus exam on quantum wave functions. The goal is much broader, a lot deeper, and arguably way more important for society as a whole. The researchers aren't suggesting for a second that we just throw out traditional, explanation-centered approaches or stop explaining things altogether. Not at all. Instead, a resonance-driven approach beautifully complements those traditional methods. You use the art, the music, and the shared communal experience to pry the door open, and then the explanation can just walk right on through.
The study actually encapsulates this perfectly, noting that this whole approach is all about, and I'm quoting here, enabling audiences to form meaningful relationships with science before, alongside, or beyond conceptual understanding. Seriously, think about how incredibly powerful that is. You absolutely do not need to master the underlying math to have a genuine, meaningful relationship with quantum physics. Just like you don't need to be a professional botanist to fall in love with a forest, you can use sensory immersion to fall head over heels for the fundamental building blocks of our universe.
And this explainer really leaves us with an incredibly exciting horizon to look toward. Because if music and art can truly unlock the heavily guarded, intimidating gates of quantum mechanics, we have to ask ourselves, what other distant sciences could we learn to feel? Could we use immersive art to finally understand the dark matter of the cosmos, or the ridiculously complex folding of proteins, maybe even the intricate, hidden networks of artificial intelligence? By moving from mere conceptual understanding to true, deep resonance, we have the power to make the absolute most complex mysteries of our universe not just known, but deeply, truly felt. Thanks so much for exploring this with me today.